Hello everyone, hope you all are doing well. So in this video we'll discuss the second problem of Leetcode Weekly Contest 347. Again, it's an easy level problem and I also feel the same. It's just that the problem statement has probably made it a little bit difficult. Otherwise the implementation is very easy. The problem name is difference of number of distinct values on diagonals. Okay, don't go with these jargons. Okay, let's see what it is saying. It says that given a zero index 2D grid of size m cross n, you should find the matrix answer of size m cross n. Okay, the value of each cell r comma c of the matrix answer is calculated in the following way. Let top left rc be the number of distinct values in the top left diagonal of the cell rc in the matrix grid, and bottom right r comma c is be the number of distinct values in the bottom right diagonal of r comma c in the grid. Okay, now the answer for r comma c is the absolute value of top left of r comma c and bottom right of r comma c. Return the matrix answer. Now what is a matrix diagonal? A matrix diagonal is a diagonal line of cells starting from some cell in either of the topmost row or leftmost column and going to the bottom right direction until reaching the matrix end. A cell r1 comma c1 belongs to the top left diagonal of r comma c if both belong to the same diagonal. R1 is less than R. Okay, similarly is defined for bottom right diagonal. Okay, so yeah, a number of definitions, but let's see what it is saying. So this is a given grid. Okay, this is the grid you are given, and you have to generate your answer grid which is of the same dimension. Okay, now what is the answer for each cell? So you pick this cell. Okay, you pick this cell. Now this cell will have, there are two things, right? It will have a top left diagonal and bottom right diagonal. What do you do? Whatever is the top left diagonal, count the number of distinct values there. Similarly, in the bottom right diagonal, count the number of distinct values there. Okay, now just whatever is the absolute difference of count of those values. For example, in the top left direction, like in this case the top left, you do not have a top left diagonal, so the number of distinct values is 0. In the bottom right, what happens? Let me just erase it. In the bottom right, what are the elements? This and this. Remember, you do not include this. Okay, because you are calculating the answer for this one. So I have two ones. So there is only one distinct element, right? So 1 minus 0 is your answer. Okay, so just see, for this grid it will be 1, for this cell, sorry. Okay, now let's see for other cells. Similarly, if you take this, top left is again empty, right? What is top left? So if you're starting from here, decrement the row by 1 and column by 1. Okay, if this is r comma c, so r minus 1, c minus 1. This is how you keep on going in the direction. Then r minus 2, c minus 2. Okay, one step left, one step up. What about the bottom right? If you're standing here, you go in this direction. That means if you start at r comma c, you go r plus 1, c plus 1. Now then r plus 2, c plus 2. Okay, so for here again there is no top left diagonal. What about bottom right? This is the bottom right diagonal. This is the only value. Okay, so now what will happen here? Again, you count the number of distinct values, and finally just see what happens. The number of distinct values that I have here is just 1, and the number of distinct values here is 0. So 1 minus 0, that again is 1. So just see the answer. So okay, by mistake I told this is the answer. Actually the answer is this: 1 1 0 1 0 1 0 1 1. So just see, this is 1. Just for second one also it is 1. Consider this: nothing at top left, nothing at bottom right. So answer is 0. Let's come to this position. Okay, nothing at top left. What about bottom right? You have one element. So 1 minus 0, you have 1. What about this guy? Now this is the top left. Okay, in top left you have only 1. So one distinct element. In bottom right you have 1. Only one distinct element. Getting it? So 1 minus 1, 0. 0 is your answer. Now let's talk about 5. Okay, let me erase it for clarity. Okay, so this is 5. Top left you have only a single element, that is 2. Bottom right, nothing. So count of element 1 minus 0. This is 1. Similarly, you talk about here, nothing at top left, nothing at bottom right, 0. One element at top left, nothing bottom right, 1 minus 0, that is 1. Similarly, 1 minus 0, that is 1. Okay, so at any given position, find what are the elements in the top left, count the number of distinct elements. Similarly, count the number of distinct elements in bottom right, just find the difference. That is the answer for the given cell. Okay, that's what we will do. So now just see the dimensions. These are the dimensions. M is equals to grid dot length, n equals to grid of I dot length. Okay, so it's an m cross n matrix. So let's come to the implementation. It is very simple. number of rows, number of columns. This is my answer array. Okay, let's start reversing. I'll calculate the answer for I comma j. So this is I, this is j. Now for simplicity, what I've done, I've taken a couple of set, because set will give me the count of distinct elements, okay, in big O of one time. So that's why I've taken it. You can take any other data structure as well. Set is a simple one, that's why I picked it. So this is S1, this is S2. This is basically count the number of elements in top left, and this is bottom right. Okay. Now I'm standing here. I have to calculate the number of distinct elements in top left. So I start from R minus 1, C minus 1. Sorry, I minus 1, J minus 1, right? So I minus 1, J minus 1. Now while R is greater than equals to 0 and C is greater than equals to 0. Okay, because these are the minimum values that it can take, 0 and 0. S1 dot add grid of R comma C, and then decrement R comma C. What this will do? This will add all the elements in the set S1 which are present in your top left diagonal. Okay, now you are done. Now start for the bottom right. So you were standing at R comma C. Now go to R plus 1, C plus 1. Again, sorry, you yeah, for this one R comma C, R plus 1, C plus 1. Here I've taken another variable name, that is why I got confused. R and C is I plus 1, J plus 1, while R is less than M and C is less than N. Okay, because I have M rows and N columns. So keep on adding the elements in S2 set. Okay, this is the second set. Okay, because it will just keep distinct elements. You increment R and C, you keep on doing this. So at the end of it, what happens, S1 and S2 have the distinct elements in top left and bottom right respectively. So answer of I comma j is maths dot absolute value S1 dot size minus S2 dot size. Okay, so you do this for all the elements and finally you return the answer. Got it? So I would say the problem statement was making it complex. Otherwise, the implementation is very simple. You can pick up any other data structure as well. But yeah, set is an easy one, so I picked it. Okay. So yeah, that's it for the solution. So if you learn something new thing, then do support it by giving a thumbs up. Do subscribe to the channel. Also, if you face any issues in this solution, mention that in the comment section. I'll revert on each one of them. Thank you. Take care. Bye bye.